Hello and welcome to time series forecasting. In the previous section, we were interested in the relationship between two variables, and we looked at a variable y which is explained by another variable x. So essentially what we are dealing here was a simple regression model, and previously we learned that how to use a simple linear regression analysis to explain a dependent variable y as a function of a single independent variable x. Essentially, the goal here was to predict variable y as a function of x. That is, if we know the values of a variable x, we can use the information contained in that variable to predict our variable of interest y. There may be other variables, those may be explaining this y variable. In some of the cases, if x variable alone tries to explain variation in y variable, our model may not predict the values of our variable of interest y pretty accurately, and it may be possible to predict this variable of interest y more accurately by including other explanatory or x variables on the right hand side. One way to extend our model of simple linear regression is to include more x variables on the right hand side. We will see that by introducing more variables on the right hand side, we are able to explain more variation in this y variable caused by these additional variables, and hence we can improve the accuracy of our model. And this model is called multiple linear regression. It is called multiple linear regression because we are extending the number of x variables on the right hand side. In the case of a simple linear regression model, there was only one variable x that was explaining another variable y. But here we are adding more x variables on the right hand side. There are many advantages of multiple linear regression model over a simple linear regression model. So the first advantage is it explains more variation in our dependent variable y, and therefore the accuracy of a multiple linear regression model is better when predicting a variable y as compared with a simple linear regression model. Another advantage is MLR deals with the other functional forms. In the simple linear regression model case, we were dealing only with a simple case where x was entering in this form linearly. This multiple linear regression model, it is more flexible because x can enter in other functional forms as well. For example, x could be entered in level as well as in the square form. In addition, we can also include interaction terms in between various x variables in a multiple linear regression model. So this is the motivation of using a multiple linear regression model rather than a simple linear regression model. We will be able to explain more variation in this y variable as explained by other x variables. And also this multiple linear regression model, it is more flexible. Obviously our point here is to predict this variable y, and in the case of a simple linear regression model, we were trying to explain our variable of interest y in terms of only one variable. But as I discussed in this video, there may be other variables, those may contain useful information to predict this y variable. So why not use that information? That is why, for practical purposes, multiple linear regression model is preferable and always used. Alright, see you in the next video. Bye bye.